I'm sharing my screen. Let me know once you're able to see the screen.
Yeah, it's okay.
Do we have any questions from last session?
Only one question, just generic question. Like, see, in this ML exams, have you gone through the question paper and what sort of questions they are asking? Is it like problem based or algorithm or just general theory or
Yes, mathematical problems.
oh maths? Oh my god. Okay.
Like similar to what we have done in DM, right? So that will, those kind of problems will be there.
DM based. Okay, okay, okay. And what about this IDS data science paper?
ITS is more kind of general statements they will give, and we have to come up with some uh, suggestions and justification.
Okay, okay. It's more like a theory, not max based, right?
Correct. But the theory questions also, right? To understand the question, we need to put some effort.
Ah,
That's it.
okay. So the ML is based
So,
on max only. Yeah?
huh.
Is it max or is it like statistics and all?
It is algorithm based.
Okay, okay, yeah, yeah. Okay, okay.
Some quick check on what we have learned last class. Uh, Suppose you want to develop a supervised machine learning model to predict whether a given mail is spam or not spam. Which of the following statements are true? We will use unlabeled examples to train the model. Words in the subject header will make good labels. Word emails not marked as spam or not spam are unlabeled examples. Labels applied to some examples might be unreliable. Any thoughts?
I think the first two will be there that we will use unlabeled examples to train the model because there can be a new case where the mail can be drafted in a different way. And the other thing is that words in the subject header will make good labels. Yes, because most of the time when you get a spam, so there is a something which is something to make you greedy or something. It's about big money or something like that. Or sometimes they generally put high only. So this can also be a good, I think. And emails are not malware spam unrelated. Labels applied to some examples might be unreliable. Don't idea. Don't have idea. What I think.
Okay. I think, let's see the answer. I
Mm.
think we will use unlabeled examples to train the model.
Mhm.
This is a supervised model. So to train the model, we need labeled examples.
Oh, okay. Sorry. Supervised model. Yeah. Yes.
And the words in the subject header will make good labels.
Mm.
Wo- The subject header is kind of an attribute they are taking.
Hmm.
So they may not use the header because header mostly it will be legitimate, right? Whenever we get a spam mail, it
Hmm.
says rewards expected. So all those motivational terms it will have. So we will
Hmm.
not be able to kind of find it.
Hmm.
Emails not marked as spam or not spam are unlabeled example that might be true
Hmm.
because whatever is spam or not spam, it is not unlabeled, right?
Hmm.
The new mails when we are getting it.
Hmm. Hmm.
And the labels applied to some examples might be unreliable. That may also be true because when we apply label,
Hmm.
we will be putting some terminologies, and that terminologies can come in a legitimate mail also, or the other way.
Hmm. Hmm.
So,
Yeah, false
wait.
positive, right? So,
Hmm?
false positive and false negatives, right?
That's correct. Give me a second. So it's the same because our label consists of values spam or not spam. Any email not yet marked as spam or not spam is an unlabeled example. The labels applied to some examples are might be unreliable. Definitely, it's important to check with how reliable your data is. The labels for this dataset probably come from email users who mark particular email messages as spam. Since most users does not mark every suspicious email message as spam, we may have trouble knowing whether an email is spam. Furthermore, spammers could intentionally poison our model by providing faulty labels. Okay. Suppose an online shoe store wants to create a supervised ML model that will provide personalized shoe recommendations to users. That is, the model will recommend certain pair of shoes to Marty and a different pair of shoes to Janet. The system will use past user behavior data to generate training data. Which of the following statements are true? So, to get a label right, it should be a quantifiable one.
I think the second one may not be a proper one, right?
So again, the when we say adores or beauty, right, it is not a quantifiable one. So for the data to generate something, it should have shoe size is one thing. So for different people, means based on their gender or some others who prefer, the shoe size is one useful feature they can adopt. So, for example, if we go to Amazon and try to buy something, based on our past purchase, it will show the size of dress or shoes and all, right? This particular size fits for you. That recommendation will come. So, size is one feature. The second is the user clicked on shoe description. So, shoe description will have some attributes which can be used for the ML. Whereas if in the comment or something, if someone type beauty or adores, those are general terminologies where it is not quantifiable. We cannot take that for the ML training data. From the description, we will get color. So all these we can take as feature. If you remember the example of the cat and dog classification, right? The clustering which we did. So
Hmm.
in that they were taking the features, the eye color, the shape of ear and all. So that those similarly some features which can be quantifiable we can use as the uh, feature for ML model. So same description they have given. If it is a any feature we are taking, it should be a observable and quantifiable measure.
So just go to the previous one once, no? Veena?
I'm sorry, that option is not there.
Okay, okay, okay.
I don't know when I start recording, right? It's not allowing me to go to the previous slide.
Maybe you can try to pause it and check.
Okay. Right. No, now both has. I might
Okay,
stop the sharing and then start.
Okay, no need.
What was the question there?
Yeah. I was looking at how you're talking. The answer you're saying that something that is quantifiable is the right thing, right? To
Correct.
choose.
This is the means whatever feature we are giving for the training data.
Right. But then one of the options that was said right there is description of it, right?
Description will have the color of the show, type of material used, all those things will come in the description, right?
Yeah, but then that is not coming under any quantifiable thing, no?
Okay. When we say quantifiable in ML, it can be either qualitative or quantitative.
Yeah, okay.
It's not only count. So
Mhm.
if it is a qualitative feature like color, some people will prefer. If it is boys, they will
Mhm.
prefer blue. If it is for girls, they will prefer pink. So that kind of analytics they can do based on that description.
Okay, fine. Thank you, Veena. Yeah, proceed. You can start recording, I think.
Okay. So what is supervised machine learning? So here we are giving some input. Supervised we already know, right? To combine input to produce useful prediction on never before seen data. But here we are giving some set of input value where we have already we know the result is like this. Based on that we are training, and once the model is trained we will be giving a other data set for and seeing whether that's results are matching. In supervised learning, each example in the training set is a pair consisting of input object and an output value. So input object will, this is in the training set. Training set will have an input object and an output value. A supervised learning algorithm analyzes the training data and produces a function which can be used for mapping new examples. It is similar to our traditional model where we are giving the rule, but this will create that rule based on the input and output. In the optimal case, the function will correctly determine the class labels for unseen instance. We will come to this definition in the next slides, but this just says for any supervised learning, there should be an input and output. Input is X, output is Y, and there should be a function f of X which will map X to Y. Any questions on that? Okay. So some terminologies which we need to familiarize, we will be learning here. One is labels. So we mentioned there is a X, there is a Y, and we are creating f of X. Or that function, not function f we are creating. So in this, Y is the label. So if you remember in DM, we have gone through a case where we identify that flower. Uh, even remember that name of flower? Three types of flower they used to classify, right? Using sepal and petal length.
Iris,
Iris. So in that we are taking an example based on certain criteria. We are labeling it as those three models, three types of flowers we are labeling. So once it is labeled, whatever labeled data is there, that is the Y. That is the output which we are expecting. Take the example of cat and dog where we are classifying. We are naming that picture as cat and dog. So that whatever we are writing that will be our label. Consider label as Y. Then we need to find what is X. We are keeping Y for something. as output, and from x we are defining that y. Then what is x? That x is the feature. For example, when we consider the cat and dog example, based on eye color or the shape of the face, nose, ear, and all, we are identifying this particular animal is a cat, and this particular animal is a dog. So whatever features we are defining to identify that feature is the x variable. So y is the label, x is the feature. They have given some example of label. Label could be future price of wheat, kind of animal shown in a picture, the meaning of audio clip, or just about any. In the spam, examples of features are in the spam detector we are telling, right? The feature could include the words in the email text, sender's address, time of the day the email was sent. Email contains the phrase one weird trick. So if these are some features, based on these features, they are finally telling whether it is a spam or not spam. Our labels are spam or not spam, and the features are they will be using all these attributes as the features. For example, a mail ID comes with @ some unknown domain, they will be able to identify it is from the it might be a spam. Similarly, most of the banking emails they will send only during the daytime. If we are getting a mail during night time or early morning, then that means it's a spam. So some categorization we can do to identify it as a spam. Those categorization are called features. Whatever input we are using to identify the final output, those are called features, and the output is the label. Any questions?
No, Veena.
And model defines the relationship between feature and label. That is the function which we told in the other one. So for example, a spam detection model might associate certain features strongly with spam. So we are clear, label, features, and model. Now training. Training means creating or learning the model. That is, you show the model labeled examples and enable the model to gradually learn the relationship between feature and label. We defined the features and we created some label for that features, and now we fed it to the model. Model will go through it and learn what is the relationship between feature and label. Inference means applying the trained model to unlabeled example. That is the testing we are doing. Once we got the training data, we created the model, we understood what algorithm we should use or what roles we should use. Then we are making that learning to make inference with the unlabeled example. So inference means applying the trained model to unlabeled example. That is, you use trained model to make use of prediction f of x or y dash. For example, during inference, you can predict median house value for new unlabeled example. So we know the house prices in an area. Based on that, for the new house in the same area, we can predict what value it will have. So all these things, right, we will be using in the coming slides. So we are learning two types of reasoning. One is inductive reasoning and deductive reasoning. Inductive reasoning is the act of generalized conclusion based off specific scenarios. So we have specific scenarios. For example, we have a basket of fruits. We took one mango, and that is a raw mango. We took another one, it's also a raw mango. Then we are creating a generalized rule telling that basket contains raw mango. That may not be the scenario. In the actual case, it can have apple or it can have ripe mango, like that it can have. But we are from a specific conclusion, we are making a generalized conclusion. That is inductive reasoning. Some of the examples are determining when you should leave for work based on traffic pattern. So we know every day after 8, Bangalore traffic will be heavy. With that assumption, I am leaving at 7:30. But I might hit the traffic, right? Am I audible?
Yes, yes,
Yeah,
Veena.
yeah.
Okay. Similarly, rolling out a new accounting process based on the way user interacts with the software. So we know this way user interacts. So we created another software, but users may not use it. The reason may be they are already well versed in the current software. They may not wish to change, or due to some other reason. So they have created, means they have a specific case where this particular tool is working or user is interacting this way with this tool. But if we give the same features in another tool, they may not use it. Similarly, deciding an on incentive plan based on employee survey. When we take the employee survey, some people will tell if you give incentives, people will the attrition will reduce. But after giving incentives, also people will take that money and use that to float in next company, right? That higher wage we will float and we will get the new job. So, but based on what survey, what it told is, if you do this, if you do this specific condition, that will do some get some you will get some generic goal. But that may not be the actual case. That is what inductive reasoning is. Whereas deductive reasoning is you have a generalized statement. So if you take any specific scenario of that generalized statement, that will work. I'm taking a bag of fruits and I'm telling this bag contains fruits. That is the generic statement. So if I take any one item from that bag, that will be a fruit because that is the generalized statement. The generalized statement is true. Specific condition will be always true for the deductive reasoning. Whereas in inductive reasoning, we are taking the specific scenarios and trying to make it generalized. That can work and that may not work. And that is the theory which we are using in supervised learning. Supervised learning, what we are doing is we are taking some specific conditions or specific scenarios and trying to generalize it. Like we are taking some mails which is spam and ham and we are feeding to the model and model will conclude this is it, but that may not be true. That is how the supervised learning works.
Okay, in this case, this inductive one, the traffic will. So the traffic shows the time prediction, right? Something like that, right?
Correct. The traffic means every day 8 o'clock we have traffic,
Mm-hmm.
but and 7:30 there is less traffic in area. We have looked at the past 1 week, and that 1 week we observed that traffic is less at 7:30, and we started at 7:30 and we ended up in traffic. So
Okay.
the first one is the training data set, which tells 7:30 if you start there is no traffic. But the second case is the test data or the actual data which is coming in, and we ended up getting stuck in the traffic.
So that because of that particular day, the traffic was happened, or is it based on the calculation errors? Or
Maybe an accident happened or due to X, Y, Z reason. There are other factors that can affect that particular model,
okay,
particular decision.
okay, okay.
Can you once more deductive learning? What type of this?
So, deductive learning is you have a generalized condition. For example, these are the books for data science. And then in that, we are taking one book, and that book will also be of data science, right?
Okay.
So, like that means we have a generalized condition, and in that, we are trying to get one specific case. That specific case will always be true.
Okay. Okay.
So, the supervised learning is based on inductive learning. From the perspective of inductive learning, we are given input samples x and output samples f of x or y, and the problem is to estimate function f. X is the feature, f of x is the label, and f is the model which we need to create. Specifically, the problem is to generalize from samples. So we have some specific scenarios or label data, training data. Based on that, we are trying to make it a generalized solution and the mapping to be useful to estimate the output for new samples in future. So why we are learning all this is there is a concept called candidate elimination algorithm and concept learning. So for that, we need to learn all these terminologies. So set of all possible instance is x. Unknown target function f of x tends to equals y. And set of function hypothesis. This is a new term coming in hypothesis. So we have a x, we have a y, and we know there is a f. But that f, how we are determining is based on a hypothesis theorem. So we can means we know x and y, then we can write due to this condition it is x to y, right? Or on this particular scenario x tends to y. So that hypothesis. Any questions?
Yeah, so Veena, these are the approaches when we have a problem of supervised machine learning. So these are the approaches that we take at that time. Huh? And so how we are going to implement it, as I have tried out, I told you na, that I have tried out this example of the gender classification on the basis of the name. Okay, so there, if I want to implement this inductive or deductive, or see that which approach was used in this, and how can I identify that?
You are asking how we can use deductive approach for the supervised learning.
Yeah. So the thing that I understand is that these are the two approaches based on the problem at your hand. Okay, either you can use the inductive learning to for the supervised machine learning, or the deductive learning for the supervised machine learning, isn't it?
Okay.
Yeah. So the question is that how we are going to implement it. It means that suppose. As inductive learning is like, I do have some specific scenario, and on the basis of that I'm concluding some theory, isn't it? Yeah. So how I'm going to implement it in the problem? It means that, do you have any
Most of the
example?
cases we will use only inductive learning. The reason is deductive learning already gives you the result, right? It's a generalized condition.
Mm-hmm.
So we already know the output. When we generalize it, any input data comes in that will fall in that condition. So most of the scenario when big data is there, or we can use only deductive learning when it is for some testing or some POC, we can use deductive learning. But most of the cases in the actual scenario, we will end up using inductive learning only. Because that is with a small set of sample data, we are trying to make a generalized conclusion. But that conclusion can work or may not work. If it doesn't work, we will use that data again, train the model, make a better generalized conclusion. So in all possible scenarios, it will be inductive learning. Most of the scenarios which we are doing, right, it will be inductive learning only.
So you are saying that providing labels is like inductive learning only. That for some sample data,
Correct.
we are
Correct.
providing some labels. That is inductive learning. On the basis of that, it create a function which verify the test data.
That's correct.
Okay, fine.
These are some of the terminologies. Training example, that is the sample data set which we are taking for the to create a target function. Target function is again that function or model role which we are setting. Concept we it's a Boolean target function, positive examples and negative example. So this terminology we will learn later. Concept we will learn later. Classifier, learning program outputs a classifier that can be used to classify. So the output of it will be, if based on that learning, if I am giving spam and ham, it will already have a classifier telling this particular data set will go to spam, this will go to ham. So that is the classifier which they have. The term learner, it is the process that creates the classifier. It is the function, but inside that function there will be a step which will create that classifier, that is the learner. Version space is the subset of hypothesis space that is consistent with observed data. So we mentioned there is a hypothesis, and that hypothesis has two parts. One is the generalized conclusion and one is the specific conclusion. And version space is the subset of that hypothesis space that is consistent with observed data. If our results are correct, or for whichever sample data the results that are correct, that will be the version space. We have an input data set or training data set. With the training data set, we created some target function which gives us the output f of x or y, or that will be the classifier. Means we created some classifiers out of it, and that model, right, that target function may not satisfy all the requirement. We are giving a generalized conclusion telling, based on this input data set, all these mails can be classified as spam. That is the generalized. Think of a box. This particular box is the generalized one where we are telling everything that falls in this will be a spam. This particular criteria or label, this will be a spam. But what we observe is there are only specific cases that matches spam. Rest everything is a actual mail. Means the sender is legitimate. In that case, this particular set of the whatever is there here, that is the version space. Just understand this terminology for time being. We will use it later in the algorithms. So we have some examples here. We need to identify what is the x here and f of x here. One is credit risk assessment.
Here fx means y, no?
Fx means y.
Yeah.
So let's take first as an example credit risk assessment. So here for the credit risk assessment, right, what all are the features which we will use? The bank will take our Aadhaar card number or the previous existing bank account details. So all those will come as the features, and they will link and see whether there are any issues with our account. So that X will be the properties of the customer. And the f of x will be based on that features, they will decide whether to approve the credit or not. So that will be the f of x. X
Maybe
is the,
based on income and expenses, and maybe the loan. So whatever is there, paid, being paid, not paid, that all come under features, and maybe the CIBIL score, which will decide, right? Is it
correct.
of that?
That will come as the f
Yeah,
of x.
it's yeah.
Similarly, on disease diagnosis,
Symptoms, past history, medical history will be X, and FX will be the report generated.
correct. X will be the properties of the patients, and f of x will might be the diseases they suffer from, or the, based on that report, they will identify which disease is there. Face recognition.
Again, the dimensions and the places of whatever nose, ear, everything, right? That would be the input. X features, I mean.
And f of x will be,
The making of a face or whatever, recognizing a face, right?
yeah, the name. If we are naming that, means
Yeah,
for our
what name
pictures
of
we
the
are
person,
naming it, then that name will be the output. And x will be the bitmap of the people's faces.
right?
Automatic steering. Again, it's also image recognition, right? So based on the bitmap images from the camera in front of the car, that will be the x attribute, and f of x will be the, means if there is a vehicle in front of it in a collidable distance, then it might either turn or press the brake, all those things it will do, right? That will be the, here it is steering, so it will decide how much it has to turn. That will be the f of x.
Mm.
So why we are doing this is, we might be given a scenario and we might be asked to get all those input and then put it in some algorithm. So the whatever features we need to select, we have to select. All those deductions will be our it's based on our knowledge, right? We need to bring it. So these kind of examples, when we go through, just think it from that perspective also. What can be the features, what can be the label, how we can use it, which hypothesis we should use, all those things, just think it through. Coming to hypothesis, hypothesis represent a function approximation for target function. It is used to associate, estimate, or predict the target value y based on the input dataset x. And in addition, we are using model parameters and hyperparameters. It is represented using letter H. The hypothesis is also referred to as a model. The hypothesis can be replaced as y equals h of x. Till now we have mentioned it as f of x. Now onwards we will be seeing this term h of x.
Here H stands for hypothesis, no?
Hypothesis, yeah.
Yeah, okay. Means it, fx and hx are same. It means function.
Kind of. It,
Okay.
if fx is a specific case and h of x is a generalized case. So initially, when we create based on target model, whatever we are creating, right, that is a function of x. Based on this x, to get y, we are doing this function f of x. But now we are generalizing that concept. That's where we have taken the sample data. This looks that this gives this output. So in order to get the similar output, we need to use that model. So in that scenario, this f of x will become h of x.
Okay, means fx is a multiple f1x and f2x and f3x, then we will generalize to hx, right?
Correct, correct. And model parameters are parameters in the model that must be determined using training data set. Based on the training data set, whatever we are making a conclusion, or whatever parameters we are taking, that is called model parameters. And hyperparameters are the adjustable parameters. So if we want to tune this model to get some optimal performance, or then we will be tuning some of the features, and that will be the hyperparameter. Just two terminologies as of now. One is model parameter, which is the x, and hyperparameter, which based on that feature we will be changing something, because not always we will get the sample data as is. So we will be tuning something to get the better model. Now coming to hypothesis space, the similar. We have many hypotheses, h1x, h2x, hnx, like that. Then everything together comes under hypothesis space. Hypothesis space represents one or more hypotheses or function approximation or models which can be created using different training data set derived from the population. So if we take this training, if we take the complete population and divide it into multiple training data set, and each training data set is giving the same results, but the parameters which we are, or the function which we, hypothesis which we are using is different, then all those things together will come under hypothesis space. X and Y are same. To get Y from X, we are using different hypotheses. So this will help us to get a generalized, get a generalized hypothesis. Once we go through each, right, combining all these, we can make a single. If person comes from this country or this country, like that, that combination works, right? So with that, we will be creating a generalized hypothesis. You will be familiar with this data set, right? The day, outlook, temperature, humidity, wind, and based on this we are telling, means we have 14 days data, and if it is sunny, hot, high, weak, then someone is not interested to play tennis. So based on these, we have yes, no in the play tennis. Either we would like to play tennis or we don't want to play tennis. This data set is from the data mining. We have this rule logic, right? So based on that, the decision tree logic. And the decision tree which we got out of that data set is like this. If it is outlook, if the outlook is sunny and humidity is high, no one will play tennis. If outlook is sunny, humidity is normal, they will play tennis. So like that, we are creating this decision tree model. So whatever final decision yes or no, that is the label which we are giving. Whether you will play tennis or you won't play tennis, that is the final label. And for that, which all attributes we are using, that are these features like outlook equals sunny, overcast, rainy, All those features we are considering, and based on that, we are arriving at this model. Any questions? So from the same data set, here we are, hello?
Yes, Veena.
Some, okay, so from the same data set, we are trying to write it as a inductive problem where we have x, f of x and h. So here x is the feature. So each feature will be humidity equals low, wind equals weak, outlook equals rain, temperature equals hot. This will come as the feature. And that unknown target function or the y part, the labeling part is y equals 1 if we play tennis on that day, and else it is 0. Now we need to set that hypothesis also. So hypothesis is derived from this decision tree. This gives an example of a algorithm, how we are using a algorithm or how we are coming up with a algorithm to get that final decision. So here each hypothesis H is a decision tree. The tree sorts X to leaf which assigns Y. So we are taking that finally when we reach the leaf branch, right, we will have that X or Y assigned. Sorry, that Y is or no assigned. Just relate what we have learned in data mining, and now the same thing is coming in the ML. So whichever algorithm we have learned there, all those things we will be reusing here.
In dysentery, how can I handle the outlier in case we have?
Whenever there is an outlier, right, we will that means the model is not correct. So that we will send that data again for the machine to learn. The first time it might fail. For a particular case, we may not be able to, or we may not be predicting it accurately. But that will go as the new training data for that system, right? So based on that, the system will evolve.
Okay. It means we have removed the outlier first.
If it is an outlier, then we need to remove. Means if there will be some cases, right? Even if it is rainy, some people will go out and play. So such
First time,
scenario,
first time also, if it is outlier, it will not fit into the tree. Then that time whether it will be keeping as a data within the repository, and next time again it will cross check that it is something which is not fitting within the tree. Then it will be discussing how it will happen. First
the,
time also suppose it did not fit.
if it doesn't fit, we are eliminating it already, right? Based
Yeah,
when we write the decision tree itself, we are eliminating it.
yeah.
Obvious scenarios we will eliminate because based on certain category we are building this decision tree, right? So if it doesn't fit in that category, we are eliminating already. Then only we will, means if you remember that the way we used to create the decision tree, we are checking something and identifying which parameter should go in the top of the tree. That's how outlook, out of all these features, outlook, humidity, wind, we are taking outlook as the root node based on certain criterias where most of it matches, then only we are making it as the root node. So the base, there will be some outliers which we are already eliminating, and if such kind of data set comes in, we will not be able to figure it out. There will be some scenarios like that, but most of it, means if it is a valid one and it doesn't fit in any of these category, it will go through the tuning again.
Okay.
think that's all I have for today.
Are you share the PPT last session also and today? I not get it. No.
Yeah, I have already shared it.
Where?
There is a Google Drive which where we are keeping all the documents, right? The peer session and all.
Okay,
Um,
okay, okay.
from the blog, you will get that link.
Okay, okay, okay. Thanks.
Yeah. Thank you, Veena.
Okay, guys,
Thank you.
can we continue the statistics later on? Someone is interested.
I have just two silly questions if anyone can answer that. Hello.
Yeah, please.
Yeah, so first
Nothing
thing
is
is that
silly.
I just want to ask that really we do need this much math in day to day job profile of data science scientist or something.
Can you come again?
Yeah, so I'm saying that do we really need this much math in day to day job of data
No,
science?
actually, we means once you are familiarized with the whatever we are doing, our algorithms and all those things, right?
Hmm.
There are a lot of or tools. If you take the Microsoft one, the Azure has a ML tool,
Hmm. Hmm.
and if you know which parameters you need to use,
Hmm.
you can easily go. Means everything is created there. It's just calling a function, and you will be able to do. You don't have to understand the underlying math behind it in
Okay.
a normal scenario.
Hmm.
But there are some specific scenarios where if you want to debug further on something,
Hmm.
then these math knowledge will help.
Okay.
At the end of the day, for the custom building, we need to learn. But
Hmm.
if we are just planning to use the AutoML or any of these tools which are available,
Hmm.
then that is sufficient. Means most of the cases these days, data scientists use that. But
Hmm.
one level ahead, if we want to do, then we need to learn some mathematics. And the other thing is when we go for these pure data scientist interviews, right?
Hmm.
One of the asks from them is the statistics.
Okay.
If you have a statistics knowledge and data science background, they will take you. We don't have to do MTech in data science,
Hmm.
but if you have a stat background and data science tool knowledge, then
Hmm.
they will prefer you.
So stat background means there will be questions related with the stats in the interview. Can be expected.
Uh, Kind of usually in interviews they will ask which all models you
Okay.
have implemented, what kind of scenarios and challenges you have faced.
Hmm.
All those kind of means no one will ask you math in interview with the level which we are going.
Okay. Okay.
But there can be means the expectation is some level of stat and math.
Hmm. 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 Okay.
Veena, actually, this is M.Tech, so it's like a prerequisite for the PhD, you know. So they are taking that research level of standards. Maybe that's the reason we are learning all this because in the operations we don't need much knowledge, right?
Kind of some of the data, right, doesn't fit into normal models. So in that case, if we want to analyze it further, then we need to means we need to do some basics mathematical modeling. So that we will be creating without the help of any tools, right?
Hmm.
So such scenarios it will help.
But in the, generally, if you go for the great learning or simply learn and those things, are they teaching so much of detailed?
Not in detail, but they also have. If you take the Simulation Data Science course, right, they have a prerequisite or elective math subject. So if you are interested, you can learn those as well. They are not mandating it as part of the course, but it is also there.
Hmm. So, Veena, other silly question is like that. I was thinking yesterday that when we label some things, okay, like a water bottle or a chips packet or something like that, we don't need this math in our head. Even we even don't know about this much math that we use in stats. Okay, but in this real world, in the when we are learning this, we need this much math. So what I was thinking, that is it a real right way that we doing? because for a child of 5 years, suppose for a child of 5 years, okay, he does not know this much math, okay, still
Correct.
he is able to label things or classify or categorize things or cluster things, isn't it? but
Correct.
but here, to train machines, we are using this much math. So might be there is a simpler way or something like that. Is there any theory behind it?
I will give you a sample a case study which one of the senior batch member has done.
Mm-hmm.
So what they have done is one of the this case study came from Kerala Agricultural University,
Mm-hmm.
and they what they have means two issues they are facing is one is nowadays in Kerala
Mm-hmm.
they are not getting people to pluck coconut,
Okay.
so they want to employ some robot to pluck it.
Mm-hmm.
So that robot should know. I mean, see, once we employ a robot, it
Mm-hmm.
should know whether to pluck the correct one. Means that there is a age for it, right? The
Mm-hmm.
period time to pluck it. So it will not know. So based on image recognition, we or some means usually for the coconut, what they will do, it is that there is a portion which attached to it, right? Based on that, they will means by looking at that image, people will decide whether to pluck it or not. So such kind of images, they will build a repository of it and then employ the robot. So that was one ask from that team. The second ask was, you know this cardamom, uh, elachi,
Elaichi.
ah,
Yeah, yeah, I know, I know.
that grows in a hilly area.
Hmm.
And nowadays they are not getting people to get it, and that's one of the costliest spices.
Hmm.
So the people they are not getting people to get it, and if we get someone without much knowledge, right,
Hmm.
how that right piece it will come means each one has two.
Hmm.
So usually how farmers do is they will start from the bottom, they
Hmm.
will plant till top.
Hmm.
By the time it ripe also it will go in that way only.
Hmm.
So they can uh, pluck it that way. So they will start from bottom. By the time they reach top, it will take 1 week or something.
Hmm.
By the time next set of this cardamom will grow.
Okay.
So that also was one of the case study which they have given. You
Hmm.
need to identify whether it is ripe or not. So such
Hmm.
kind of cases, right? We will create lot of images
Hmm.
where we know how it is
Hmm.
by looking at the plant itself, right?
Hmm.
The experienced people can tell this particular cardamom is ripe, you can pluck it,
Hmm.
and this is not. So they either it is based on the color or the size and all they can determine.
Hmm.
The second is there will be flower, leaf, and all, right? When we employ robot,
Hmm.
it will go and pluck everything.
Hmm.
So all those images they will capture in repository and they will label it as leaf. So when you get one image, it is easy for you to label it.
Hmm.
But will you be able to label 500 images or 5,000 images?
No.
So that repository it will slowly create. The
Hmm.
first time it will create whatever label we are giving, it will
Hmm.
create a model.
Hmm.
Then based on the next images they are getting, it will run the model,
Hmm.
and someone has to manually correct it.
Hmm.
So in supervised learning, always there is a manual correction happening. So
Hmm.
we are deploying the model to business. Business will tell
Hmm.
this particular set of data is coming correctly, but when I start pushing this particular source data,
Hmm.
it is wrong.
Hmm.
Then we need to use that data to train the model again. So to understand that, sometimes means that basic level of learning may not be enough, we might need to do some advanced. So such scenarios we might employ. So we might take the mean, or based on the color combination, we will do some gradient and all. Then we will determine, because everything we cannot manually label, right? So we will employ some tools for that. We will come up with some logic to label it. So all those things we might need to employ to get a good model.
Got it.
Okay, Veena, thank you so much.
Thank you, Veena. Thank you so much.
Thank you all.
Thank you all.
Thank you, Veena.
Thank you all. Bye.